All right, guys, here is the final video. I hope that your spring break has been going well. I'm looking forward to seeing you soon. So this last video is going to deal with rational functions. So we're going to take a deeper look into rational functions. You should have spent a little bit of time reading the definitions and some important information about rational functions above this video. And so I just wanted to quickly remind you about the basic function and what it kind of looks like. This is what our parent function kind of looks like, y equals 1 over x. That's the most basic rational function we can have. Definition of a rational function, we've got to have a variable in the denominator, okay? Because what's not a rational function is maybe something like this, right? Where you've got a fraction, but the variable isn't down here, okay? And so what this looks like, again, is kind of a strange looking graph, okay? And some important things to remember about this is we've got some asymptotes here, right? So we've got a horizontal asymptote here. That's an imaginary line that your function will approach, right, but never cross. And then we also have a vertical one right here. So this is at x equals 0, right? And this one is at y equals 0. Okay, but again, we can transform this a lot of different ways. So this graph isn't always going to look exactly like this. Okay, so first thing we're going to take a look at is finding horizontal asymptotes. Okay, so again, right here, what you'll notice is this is what I had just graphed by hand. We have a horizontal asymptote at y equals 0, right? But what I want you to think about is this is something that the function can never be. So looking at this equation, how could we actually find that horizontal asymptote? And you can pause the video and think about it for a second. But if you think about it, we know it's at y equals 0 because we can visually see it. That means that, right, think about it, 1 over, if your x value is 0, this is going to be undefined, okay? And so maybe it has something to do with this down here. Maybe it doesn't. Let's see. Okay, so I'm going to go through some rules here. Okay, this is how we're going to determine if we have a horizontal asymptote. Okay, so all this means is a fancy way of saying it's just a mnemonic device, these things right here, and I'll explain what they mean in a second. But, okay. In each of your types of equations, these rational functions, you are going to have a leading term, right? Some leading degree. And remember, the leading degree is just the highest exponent, right? Okay, so essentially what we're going to be doing to determine the horizontal asymptotes is we are going to be comparing the highest exponent in the numerator and the highest exponent in the denominator, okay? So in this instance, it's x squared over x squared, okay? So that means that these two have the same leading degree, right? The same coefficient, this same degree, not coefficient, okay? So looking at our rules here, if we have a horizontal asymptote, well, in the numerator, is our degree smaller in the numerator and bigger in the denominator? No, right? Is it the same in the numerator and denominator? Yes, okay? So what that means is that our horizontal asymptote is going to be at y equals whatever the leading coefficient is divided by the leading coefficient, okay? So looking at this, our coefficients, these are the same. So our coefficients are 1 and 1, which means that I have a horizontal asymptote at 1 divided by 1, aka my horizontal asymptote is at y equals 1, okay? Now, what this means, eats DC, that's a mnemonic device, okay? That just helps you remember this rule. Eats DC stands for exponents are the same, which they are, right? DC means so divide your coefficients, right? And that's, in fact, exactly what we did. Now, in this case, the coefficients happen to be 1, which was nice. Okay. All right, so let's take a look at this next example. We've got y equals something like this, a rational. Now, this is to the first power. I'm going to compare my leading degree in the numerator to my leading degree in my denominator. That's this. Okay, so do I have smaller degree in the numerator and larger in the denominator? Well, is 1 bigger than, smaller than 2? I think so. So we have this situation, right? Which means that my horizontal asymptote is going to be y equals 0. Don't even have to do any work. Okay. Now, what this BOBO, this is eats DC, what the BOBO mnemonic device stands for is, if you can guess it, bigger on bottom, which means I have a coefficient of 0. I mean, not coefficient, horizontal asymptote of 0. Bigger on bottom, BOBO. Okay? All right, and the last one here, we've got the highest degree in the numerator is a 1. This is a 3, so we're comparing these two. So it's still, 3 is still bigger than 1, so it's still BOBO, right? Which means, excuse me, that we have a horizontal asymptote at y equals 0. Now, if we had a situation where there was a larger degree in the numerator and smaller, bigger on top, that's what this stands for, we are not going to have a horizontal asymptote, so no horizontal asymptote. Okay, so you don't have to worry about that. Alrighty, so that's horizontal asymptotes. We're going to take a look at 2 more. So that's horizontal asymptotes. So if you want to take a break, I think that's a good idea. Maybe check out some horizontal asymptote problems, okay?